In the near future, we could see the emergence of smart factories and industries which combine automation and artificial intelligence to facilitate the 3D printing of unconventional things like food and houses. All of this and more on today's podcast. Hello, and welcome to the Hard Tech Podcast. My name is Daniel Apo. As some of you may already know, I'm a mechanical engineer and tech entrepreneur. My previous experience includes building a hardware company, a hardware startup in the energy space. And joining me today is Riley Knox, the co-founder and CEO of Accelerate 3D, creator of something called Smart Factories. Thanks for joining me today, Riley.
Yeah, thanks for having me. I'm excited to talk about really fun hardware and hard tech stuff.
Yeah. Let's just jump into it real quick. Just broadly speaking, how does a smart factory work?
Yeah, so the whole plan is to make like autonomous production facilities. So these would be to where instead of thinking about each individual piece of equipment as a standalone piece of equipment doing a single step in the job, you think about it as the entire factory as one piece of equipment, to where you have all of the individual pieces of equipment inside of it are interconnected and talking to each other, so that as something progresses through the workflow, it can happen ideally autonomously, but that everything is tracked, everything is actually monitored, so that you can get to the point. The big vision would be down the road getting to the point where it's just raw material comes in one side, the actual final parts go out the other side, with the absolute minimum amount of human interaction between those 2 points. And the whole concept that we were going with was centering that around 3D printing because of its flexibility, its adaptability, and trying to make an entirely new system for how things get built, and then doing it regionally. So setting up a bunch of these facilities across the U.S. so that you're doing that production as close to your customers as possible.
Sounds very interesting. So is that something that involves a lot of automation on the AI side of things, for example?
Yes, definitely on the software side, the keeping track of things on the back end side, and building out how you would monitor that entire process. And then even just down to like robotics, ideally too, to move things from one step to the next.
Okay. Well, I just wanted to make sure we got that, intro in so that we set it tone for the entire discussion today. But before I get into, more technical stuff, I just want to talk about your background. You have a distinctive background and you have a lot of experience as a mechanical engineer and as a hardware tech founder. So just tell me what's that been like?
Yeah. So mechanical engineer, graduated from Texas Tech. Before I had even graduated, started working on my first company with a couple of guys that I met through the engineering department. We were doing meteorological towers for validating potential locations of wind turbines. And just 3 of us, did probably over $1 million worth of engineering and fabrication work ourselves over the period of like 4 years. And we built our own CNC plasma table. We built our own welding robots. We built gigantic, super accurate welding jigs. One of them we built was 35 feet long, and it could take dirty, warped, inaccurate, hot-rolled steel and spit out a truss that was within a 64th of an inch or maybe 1/28th of an inch over that full 35 feet, which we were pretty happy about when you're talking about welding stuff up. Went through that whole process, built all that stuff. We were in the process of building our actual production prototype of doing everything how we would really do it. Mm-hmm. And then Congress decided not to renew the production tax credit for the wind industry. And our market disappeared overnight. And we didn't know when it was coming back. So we couldn't justify how much we were burning and how much we were spending. So we kind of wound that down. And before that had even finished, I had already come up with this design for a new type of FDM 3D printer to be able to do large size things. So when I moved back to Austin, I decided to take a shot at that and turned my garage into a workshop and started designing and building the prototype machine. I'd personally never even used a 3D printer before I had fully built or fully designed and mostly built the prototype machine. And now it's patented and took that company through Techstars and raised a pre-seed and did all that fun stuff.
Fantastic. That's a good is a good time to get into like 3D printing discussions, right? Just before we get into like what you actually worked on, let's talk about some unconventional things that are 3D printed today, and I want to get your take on them. Let's start with 3D printed food.
I understand the novelty of it, and there are some interesting potential aspects when you're talking about like 3D printed, I guess meat would be one of the things of maybe trying to recreate or simulate the physical structure of it. I do think that a whole lot of it is just novelty. Granted, you can make a lot of money off of novelty if people like it and want to take advantage of it. But as far as like somehow making food better, I'm not sure that 3D printing offers anything other than presenting it in a new, cool way. Okay.
So for some of the researchers and the companies working on this, and by the way, some of them have actually gotten FDA approval. Like there's a restaurant in DC right now that's offering 3D printed food. But think about this, right? For some of them, what they do is it takes stem cells from the animals and try to like simulate the growing of the stem cell inside the animal to form the flesh that you end up eating. So in a sense, it's like growing meat outside of the animal.
But none of that process requires it being 3D printed.
Yeah, that's true.
Because that one of the I haven't personally gotten connected with them, but one of our customers who's letting us use space in their facility knows one of the outfits that just got, I think it was just they just got FDA approval for selling lab grown meat. Like it was a big thing, and they were talking about 3D printing it too. And my whole question was, why? Because the 3D printing is not an integral part of like the growing of it, at least in my understanding, that it's more so you're using it as a bioreactor setup to stimulate these stem cells into growing and reproducing. And then it seemed like what they were using the 3D printing for was to then try and recreate macrostructures that you would find in the actual substrate of whether it's like a steak or chicken breast or whatever, because you have the different types of material that are in there, whether it's the actual fibrous muscle tissue or connective tissue or distributed layers of fat or stuff like that I guess kind of makes sense, but that's more of a presentation setup for it as opposed to the actual process of being able to do lab grown meat, which I think is going to be a huge thing. The thing that and they probably are doing it, but my first thought was y'all just need to be making a ton of chicken nuggets. Because I mean, that's basically just they ground up whatever is left anyways. You can't tell what it is really. So even if it's just a mass of cells and muscle and all of that stuff, and you're basically just like pressing it into chicken nugget or chicken strip shape things, that still in of itself is a huge market potential. And just on the fact that one, like there's the ethical benefits of you're not actually having to kill something or raising it just to then eat it, but there's huge sustainability benefits too, because you're using like 90% less water, you're using a whole lot less energy, you don't need nearly as much land. It just makes the whole process much more efficient. And it also makes the process safer too, because you're talking about producing this stuff in a perfectly controlled lab environment to where you're much less likely to have things like salmonella or any of these other viral or bacterial outbreaks that we've seen spread through the way in which our current industrialized food system works, which isn't always about safety. It's always about profit and then kind of maybe safety later. But when you're talking about this setup, you maintain tight, full process control on everything through the whole way of it going, to where now you're talking about the potential of also creating a much safer product that is also more sustainable, uses less energy, and you can tailor the actual like fat content, nutrient content, all these different things to ideally also make something that might even be healthier to people, because you could focus on having like higher levels of beneficial omega fatty acids or stuff like that. There's some interesting things that can be played around with on that side. And I'm sure they've thought of all of these and are working on playing around with those. This is just my very limited understanding of it as a general tech and hard tech nerd.
Yeah. Yeah. Yeah, you were right about how the 3D printing part is probably just the final, I don't know, the cherry on top. Like, a way of presenting the food in a certain way.
Yeah, it's a fun, kind of more palatable presentation, as opposed to just like a big gloop of cells.
Yeah. Yeah, so more of a customization thing. But yeah, okay. The very interesting one I saw was 3D printing of fish fillet, and you could just see how it looks. It works well for some premium type foods like caviar, foie gras, things like that, where people just want it to look a certain way, and it makes the chef's job a bit easier. So maybe.
No, that makes sense. Yeah. Because at that point, you're talking about what people have experience with, what they understand, what they already find appetizing and appealing. And so it's trying to maintain what people already understand, because that makes it a much easier lift to convince people to try it out if it already looks like what they know and understand. And that was the whole reason I was saying like chicken nuggets, because everyone knows and understands chicken. Or if you want to do fish sticks.
Yeah. I'm beginning to realize that chicken nuggets is the universal child's meal everywhere you go. It's funny. Yeah.
They're simple. They're I wouldn't say healthy, but there are much worse options that people could go with. And again, it depends on like where you're talking about getting stuff from. Because it's like with data science. If you have garbage in, you have garbage out. And if you have kind of garbage feedstock going into the chicken nuggets, what you're going to end up is going to be with kind of garbage. But if you have like really good higher quality stuff, you could actually be talking about things that are reasonably healthy and beneficial.
Okay. How about 3D printed houses?
3D printing houses is an interesting proposition. I would say it's kind of a bit too early to tell how well it's actually going to work. Because when you look at a lot of the ones, so there's basically two camps. There's one camp I'm fully on board with, and I think it's a fantastic game-changing technology. There's another one that I'm very much unsold on so far, because there's just so many unknowns, and I don't think it's fully demonstrated a lot of what people are claiming. I'll start off with the one that I'm not fully sold on, and that's the one's 3D printing concrete. So like Icon here in Austin, there's a few other ones that have started to pop up. One, they're not actually using concrete. They're using their own proprietary new blended material that is much more akin, at least in my understanding, to mortar than actual concrete. So now you're talking about how long will this stuff actually last? How durable is it? How structurally capable is it? There's a whole lot of unknowns when you're talking about more or less a new material. Also, at least on a lot of the projects that I've personally seen, it still seems to take forever to actually build the frame. Like there's, I got to go tour it, and maybe it's because they're still testing out and validating and working out the kinks, but I got to go see the one that they were doing at Camp Mayberry here in Austin. They're printing a innovation center for training soldiers in I think like IT and robotics and stuff like that, kind of next generation technology. And it's a decent sized building, but I mean, I'd say it's kind of on par with like a 3 or 4 bedroom house that has a detached garage, like a good size house. And they were talking about how it's going to take them 6 weeks just to print the frame. And all I'm thinking is they're building houses in my neighborhood right now that aren't much bigger than that. Yeah, maybe that's like twice the size of these houses, but they go from having just a like concrete pad to having it fully framed, which that's all the 3D printed concrete just replaces what would normally be stick and frame. They have that up and done in like 2 or 3 days, like maybe a week tops.
That's true.
So you're now talking about, at least from what I've seen, granted, it's probably still working out the kinks, figuring out. It doesn't seem to really be saving that much time on that specific effort. They keep talking about being able to do it in 24 hours, and the only thing I've seen them actually do that time was like a very small, tiny little thing. You also have the issue of you need your machine to be, by definition, bigger than the building, the way that they do it. So that presents its own challenges. I definitely think there's huge possibility. They're working on some cool stuff when it comes to integrating the actual kind of final workout on the facility. So when you're talking about electrical and plumbing and all these other different utilities that need to be included in, and being able to incorporate the ways in which those are put in, that does have some potential benefits, but I'm not fully sold on that way of doing it. That said, there is an entirely other way of doing that I am 1,000% sold on. The best example of it is a company out of Australia called FBR. Used to be Fast Brick Robotics, and then they shortened it down to FBR. And their strategy is, instead of taking a liquid material and depositing it layer by layer, they start with larger size, like established bricks. These are basically cinder blocks. They're a very specific shape that they've kind of come up with, but they're manufactured in the same way. They have the same physical properties, all that stuff. And it's basically a truck that pulls up. It's got a big, huge boom arm on it. So it looks like a pole work truck or something like that has a bucket truck, except it extends out. And on the end of it, it has a laser stabilized robotic arm. And it has a carriage system that feeds the bricks through the boom from the actual main truck. The arm grabs it, puts structural adhesive on it, and then sticks it right where it needs to be. And it can do something like thousands of bricks per day. It can actually do the full frame, like to where you're now talking the frame is solid, like well-established construction bricks for an entire house. And it can actually do it in a day or two. And you don't have to set up a track system. You don't have to have some gigantic machine that's bigger than the house. It literally parks in the front yard, and its boom can reach 100 feet. And you just load pallets of bricks into the back of it, and it starts stacking everything up. That one is very, very cool and very promising, and especially because you can use, because they know which brick is going to go exactly where, you can include pre-cut channels for like your electrical and plumbing into the wall that already get routed and established. So when the tradesmen come in to run the electrical or to run the plumbing and stuff, they've already got the paths already all marked out in the wall to where they're literally just doing the hookup. And now their job has become way easier because they're not having to cut channels or figure out paths or any of that stuff. It's just, got a point there, got a point there. The path is already right here. And they just go lay everything in and rock and roll from there.
Wow. Okay. The only ones we see, right, online, right, are the ones where you see like you see a layer by layer construction of the building. And I keep wondering, right, it looks like a continuous structure, but you and I know that you're creating weak points along the way. Every single layer to me seems like every single layer connection is a weak point to me.
If they're managing, this is the whole thing of why they had to develop their own material, because if you try and 3D print with just normal concrete, it doesn't hold its shape. Like normal concrete slumps. That's actually one of the ways they judge the mix of a concrete, is what they call slump test, to see how liquidy it is. Like they basically put it in a bucket, turn it upside down, and lift it up, and they take a measurement on how much it spreads out, because they want it to. You need it to have a certain amount of flowability for it to be good concrete. But their stuff, they need it to really hold its shape and not do that. Now, I think a lot of what they're working on is how to actually manage the process to where they're giving it just enough time to kind of cure and harden while still being uncured enough to where you can get good bonding to the layer that forms above it. But they still usually, at least from what I've seen, only end up doing like blocks of height per day, to where they'll maybe do like a meter or a half a meter per day. And then at each one of those layers, now they're putting like rebar and other things in. Yeah, you're talking about a cold joint there of where those didn't fully join together to where you're having a fully cured layer and then putting more material on top of that. You don't actually have that physical bond. And that's kind of what I was talking about on, we don't know how well these structures will do with time. Because when you're talking about like, yeah, you can do advanced weathering testing and other ways of doing those kind of validations and testing. But at the end of the day, like have a building sit there for 20 or 30 years. That's a different story than like putting it in an accelerated aging chamber for a week or two.
Yeah, and have the building subjected to weather conditions, mild earthquakes, tornadoes, hurricanes, things like that.
Yeah.
Yeah.
And I mean, we'll see. Like maybe they have it fully figured out. I just haven't been fully sold on that yet, especially since all of the examples that I've like seen or been made aware of, it doesn't seem like it's really that much faster. And the buildings, like the houses that they did here, aren't any cheaper. They're selling them for $300,000-$500,000, just like everything else around it. To where I'm like, okay, cool. I guess if you actually manage to save money on the framing, it all goes into your pocket. Okay. But it doesn't benefit the customers. It doesn't benefit the people in the community. All you're basically doing is figuring out a way for you as that fabricator to make more money, which I mean, good on you, good for your investors, but that doesn't actually move the needle for society.
So basically it's not faster. It's not, we don't know if it's better. And it's definitely not cheaper. So it doesn't satisfy any of the...
At least on a lot of the examples we've seen so far.
Yeah.
And especially the ones that I have personally seen. Could become like the next big, huge thing. They are working on like doing some like printing a whole bunch of these where they just set them all up in a row and have the track constantly moving down. But at the same time, every time I see that, all I'm thinking is, wow, it would be so much easier if they just parked a truck in the front yard and it reached out and did everything with a boom arm, and you didn't have to set up all of this actual physical infrastructure just to be able to put up a frame.
Yeah. Last discussion on this topic. Is there anything that we make today that would be better 3D printed?
Lots of things. I mean, better is an interesting term, because what it kind of comes down to is there are a lot of things that we make and use today that it would make sense to incorporate 3D printing into the process at some point. So, I mean, there are a lot of things, especially if you're talking about, so the 3D printing we use is FDM 3D printing. So you're using a filament, melting it, putting it out layer by layer, basically a tiny version of printing the houses. But it looks very similar when you kind of zoom in on them. There are tons of products out there that can benefit from the flexibility, the cost effectiveness, because one of the big things is with 3D printing, you don't have to have a mold. Like if you're going to make this lower casing for this microphone right here, this was either machined or injection molded, which means you either have to have some sort of tooling or setup for it, or like this knob right here. This was injection molded, which means you have to have a mold created for it. You have to run it in an injection molding machine. And to make that actually all work, you need to be doing tens of thousands of these, if not more, all in one shot. What if you need to change the design? Now you got to toss that mold and start all over again. That's where 3D printing really shines, is that you can do, and like even with us, we're cost competitive with injection molding into the thousands and even tens of thousands of units when you take into account the cost of the mold. A lot of people will say like, oh, it only costs injection molding like $1.50 or like 50 cents to make this part. And then you asked how much was the mold. Oh, it was $15,000, and we're only making 1,000 parts, and now you just tripled the cost of the actual part.
Yeah. I mean, people tend to forget that if you're making a product, you sell 1 million units, sure, but most people can't sell more than 1,000 units or something. And
there was actually another 3D printing service provider out there I think they're in the process of finishing up. They got an order for 1 million parts, and they're 3D printing 1 million parts for a customer. They weren't the cheapest option, but they were actually able to get it done in the amount of time that it needed to, because We were like from supply chain interruptions, from factories being shut down overseas to all these other things, the customer was willing to pay a bit of a premium to actually be able to get the things they needed. Because that's the other thing is 3D printing. Like if somebody comes to us and they say like, hey, we need 10,000 of these printed. Like we did just recently finished up an order that was 1,000 parts. Like we were taking parts to them the next day. They were here in Austin. We were just starting to drop stuff off, either for them to test and validate, or like if they actually were in need of them, you can have parts start showing up that week, which opens up a whole lot of possibilities in how people set up their production setup, how they run their operations.
You can't do that with injection molding because you got to pay that cost for the mold first.
That and everything shows up all at once. So you'll wait like 6 months and then you'll have 10,000 parts show up as opposed to having a chunk show up every week, which means now you're talking about having to have a massive inventory to where you have like space to put all these, to store them as you work through them, as you sell them, versus you just every week having so many show up. You're building whatever your thing is. Our target was mostly drones and robotics. So they can be building out those, selling them, not having to maintain huge inventory. And if they need to change something along the way, they just update the CAD file. And if there was a substantial change in cost, we would basically just bill them for the difference.
You know, this makes me think a little bit about, we live in a world, right, where for most things, or for most people, if you're not making $1 million of something or hundreds of thousands of something, then no one really cares to design systems and processes for what you need. You could sell 1,000 of something and make a very good living out of that, like 1,000 a month of it, right? And there's no system designed for that. Sorry, go on.
Well, so this is where it gets really interesting, because say if we're talking about, like, yes, what you're talking about is usually people think in the order of like thousands or tens of thousands. I think Toyota doesn't consider something mass production until they're making 25,000 of something. But the thing you have to remember is, say if we're talking about this whole setup right here, of you've got this boom, you've got the mic, you've got all this stuff. This you could view as one thing, but it's one thing that probably has 50 parts in it. And how many of those are injection molded? Because each one of those now needs its own mold, now needs its own like runtime on a machine, now needs its own individual all steps, to where you're not usually talking about just one part. You're talking about a lot of different parts that are going into one thing, but now each one of those things, you're getting rid of that other associated costs. And I mean, like at some point, if they scale up to where it makes sense for them to go to these more traditional ways, then but that break-even point of where that shift happens has moved out massively in the last 3 to 5 years, to where I don't think a lot of people even fully understand, because a lot of engineers, even the ones that we talk to, younger ones that have gone through like high school and college and have a more intuitive understanding of 3D printing, get it, but a lot of the old guard engineers still think that 3D printing is just something for prototypes or one-off or stuff like that. And I'll say to them, no, we could do thousands of parts and it will be quite often cheaper than injection molding, if not cost comparative enough to justify paying a bit of a premium to be able to get them next week versus if you're lucky, next month.
And I'm thinking about things like where economies of scale goes out of the picture a little bit with some types of products, where you could, for example, if you wanted to compete with, say, a product that is being sold at Target, right? Target probably sells 10,000 units of this product every month, right? But you're trying to compete, and you could make a good living selling 1,000 units, right? You can't compete on price if the manufacturer is giving you something like giving you a price that's very expensive because your number of units is lower. But then maybe you have a product that customers want, right? You have a different value to provide, different from what Target, the big company, is providing, right? Then you can't compete simply because you're stuck with a system, the injection molding system, or some other system of manufacturing things that is just not efficient as it. at a medium scale, not even a really small scale. You're not making 10 units, right? You're making 1,000. It's really sad because this subject actually is very interesting to me. And what do you think it would take to have systems set up where something like that can flourish, where you can make a medium-sized amount of products compete with large scale retailers, if you will, and still be able to compete on price?
I mean, those already exist. There's starting to be other companies that are building out, because with 3D printing, the way that you get economies of scale isn't the same as with traditional manufacturing. The way I usually think about it is traditional manufacturing is more like the CPU in your computer, to where you'll have like a handful of cores that are super, super fast and have really high throughput. You can think about those as like an injection molding machine or vacuum molding or one of these other things that can just crank through hundreds or thousands of parts per day, but they can only do that one part. They're very optimized, very streamlined, and very, 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 very fast. The way you think about 3D printing and how you scale it is more thinking about the GPU in your computer, to where you have a much larger number of slower processors splitting up the work and working in parallel. Yeah. So it's not about having just like one 3D printer that can go that much faster to be competitive with injection molding, because I don't know if we're certainly not going to see that for probably a decade or two, if ever. But the way you do it is that you have, if you want to be producing parts at the same speed as injection molding, and say your printer is 1/100th the speed. So in the amount of time that your printer can produce one part, that injection molding machine can produce 100. The way you scale up on 3D printing is now you just have 100 printers. And you just have them all working together, splitting up the process, and you have them all networked, and you have a back-end system that's monitoring the entire process. And at that point, it's just making sure that the actual cost to build and run the machines makes sense for the throughput and volume and the types of products you're producing. Right now, it's really hard to be competitive for consumer-based products. That's what we found, is because people are cheap and they want the cheapest thing possible. They also usually have very specific ideas in mind about what a product should look like as far as surface finish or stuff like that. That's why we focused almost entirely on B2B, on focusing on industrial robotics, drones, things like that, because they just want something that works and that is functional and capable and strong and cost effective. And that was where we really kind of hit hard.
Well, that reminds me of a question that's very critical to my heart. When you're building a hardware company, right, a hardware startup, typically, if you're trying to build a company that would provide products to consumers directly, you're going to run into problems with VCs being squeamish and with your product being easily copied, and you get everyone telling you need to do B2B. Or you find out by yourself later on that B2B is the best way to go. Yeah, let the big companies fight the copycats and whatever, right? Does that mean that we're handing over consumer perception, consumer education, consumer how do I put this? The perception consumers have of what a product should be like. Because you mentioned something about that consumers already know what they want. Now, we're handling that entire education system, if you will, to big companies.
Well, I wouldn't say we're handing it to them. They already have it.
So we can't. So there's no way for a small company starting up, maybe not a raw startup, but a smaller company to basically change the perception of the consumer base, basically, on what a physical product should look like.
I don't think that's true. I think that happens all the time. It's just hard, like really hard to do that.
Yeah.
And if you're talking about trying to do that while also developing new technology, while also trying to build out new systems and new ways of doing things, at some point you're just stacking so many hard things on top of each other, and each one of those layers decreases your probability of success. to where at some point it makes sense to start taking layers off. And one of the easiest ones is to just not work directly with consumers. That doesn't mean that you can't end up working with a company that's working with consumers. Like a few of the ones that we have worked with, they sell stuff to consumers, and we just produce stuff for them. But that was still really hard to kind of hit what the margins they were looking for versus if you are building a drone that someone is going to use to do inspection of like aircraft and jetliners. They're willing to pay a lot B2B. More for that setup because that's a very specific niche solution that requires an understandable increase in engineering and complexity that would then come with an understandably increased amount of cost associated with it. That for a company is acceptable, but for an individual consumer, like they're not going to pay $30,000 for a drone, but to use it to automatically or autonomously inspect an entire aircraft, it costs you $30,000 for the drone, but now you're able to save tens of thousands of dollars a month in like labor costs or potentially missed things or downtime just because now you can have this thing working continuously.
Wow. Just during this conversation, it just dawned on me on how public perception is really controlled by a few entities.
Oh, yeah.
And I've had this discussion with even like people who build software companies predominantly, and it's basically the same thing. And when
no one ever got fired for choosing IBM, or now it's no one ever got fired for choosing Microsoft.
Yeah. Wow. Okay. This is a good time to get into the topic of advanced manufacturing, and if you think advanced manufacturing should be brought back to the US or not, and if so, how do we bring it back? What do you think?
Should it be brought back? Absolutely. If nothing more than for a strategic safety factor to it, of having too much of the things that you depend on being entirely produced somewhere else, to where if things change internationally, that could present a huge challenge for your populace. I don't think that's ever really a good idea. In some ways, like it can make sense to have things distributed and have those options in place, but I think we went way too far on the low cost at all cost approach, and we're starting to see the negative effects of that, especially like when you look at producing things over in China. In the last, was it 10 years, labor cost there has gone up 16-fold or something as they go from being kind of a lower income to more of a medium income country. They kind of expect that increased standard of living, which comes with more cost. And the problem is how we've set everything up is relying entirely on cheap labor, to where you now see companies moving to either Vietnam or other places that still haven't fully developed, or even Mexico to some extent, which that one is a much better option than going across an ocean, just because we have pretty good relationships with Mexico. They're right next door and offer a lot of benefits on that side. But I think we need to be bringing back as much as we can. One, just like I said, for strategic, I think it's just a good idea. But also it gives us back control of our own destiny and what gets produced. Now, the problem is we don't really have cheap labor here anymore, which means that if we're going to do it, we need to do it in a way that takes the maximum advantage of what we do have, which is high-skilled, high-capability labor, to where you have a smaller number of people managing a highly automated and autonomous process, as opposed to having a whole lot of people doing all those individual steps manually by hand.
Yeah. Okay. So bring back advanced manufacturing by leveraging advanced capabilities, basically.
Yeah, pretty much. And one of the things, too, that like Tesla learned this the hard way is that you kind of have to do it in a very smart way, which usually means doing it the non-advanced autonomous way first, seeing how it actually works, identifying the low-hanging fruit that's easiest to start to automate, and then you start there and start figuring out how to do each one of those steps. Because they went through and built out their new factories when they started building these and had just everything was robots. All of it was robots. And then they ended up ripping out most of it and putting people in because the robots actually weren't good enough to do every task. So they were like, okay, we got to have people back in. And then they started seeing how people and what tasks were being done and started identifying like, oh, we can automate this bit here and this bit here and this bit here and start figuring out this one here and this one here. And as the technology progressed, it made sense to incorporate back in automation in specific areas. And that's kind of how we're going to have to do it to really get to large scale back here in the U.S. is because people just, like, we don't have cheap labor here, so we have to get creative on how we actually build things.
Yeah. So, but leveraging, I mean, I don't want to talk about getting to the topic of AI or all that stuff, but leveraging advanced capabilities means using a very limited part of the workforce. So it doesn't bring back jobs necessarily, and to the extent that most bring back jobs to America type people would want, right? So then all you're solving with that is the safety factor, like you said, or returning in the United States to the manufacturing powerhouse status, right?
Ideally, one of the things that I always kind of push back on that idea that it doesn't bring back those jobs. Like, yes, it doesn't, but those jobs aren't here right now anyways. So it's not like it isn't a net negative. It's not like bringing back manufacturing in a highly autonomous way to the U.S. is getting rid of jobs that currently exist. Yeah. Those jobs don't currently exist. You're bringing new jobs that do, and yeah, they are targeted at much higher skill, higher educated workers, but that's still better than nothing. Because the only other option would basically be trying to do some sort of artificially funded make work program of forcing to use lower skilled labor but still paying them at what Americans expect to be making, which means the products are no longer going to be profitable because they would cost more than those same Americans would pay for them. Yeah. Which means that it's entirely an unsustainable thing. So that's how I've always thought about that like even the facilities that we had in mind, like a lot of people would kind of bring that up too, like, oh, you're only going to have like a handful of people working there. That's not really moving the needle on bringing back manufacturing jobs. I'm like, that's still better than nothing. Yeah, like those handful of ones are really good, high-paying jobs that aren't there now, and it's not like they're replacing jobs that are there now.
Yeah, true. And it's easy to forget the fact that some dead support industries will probably come back to life, right?
Ideally, yeah.
Real estate, agro, food, whatever. Things that support the manufacturing industry will come back to life. And those may require low-skilled labor, right? So yeah. I agree. Okay, so you already touched on this topic a little bit about consumer sensitivity to pricing of products. So we know that this is one of the reasons why manufacturing went abroad in the first place and why it keeps going overseas. So, smart factories, other systems that are similar to what you did with Accelerate 3D. How can these compete price-wise, and is it just an issue of economies of scale?
That's a really good question, and that I think is going to come down to each individual product and whether or not it can compete on price. Because one of the other things, like the reason that we ended up with the system we have right now was not driven by price sensitivity of customers. It was driven by companies recognizing that they could make much higher profit margins by shipping jobs and manufacturing overseas. They didn't lower the price of the things they were selling when they shipped all the manufacturing overseas and cut their actual cost by 40%. It's not like products got 40% cheaper. They kept charging the same amount and just made a shitload more money. that wasn't the driving force on the system that we have now. But as time has progressed, the actual labor costs here have continued to rise as standard of living and what people expect to have has continued to rise to where now it is something that we would kind of have to take into account. But I also think it's probably not as much as people try and make it out to be, because they're still trying to think about it on the same profit margin model as having ultra cheap international manufacturing versus doing it here, still being able to sell it for the same price, but you just have not quite as aggressive of a profit margin. They're still trying to say like, oh, we should still have these like really high margins on all of these things versus going back to when it was much more reasonable profit margins. Companies aren't going to like that because it means their growth is less and is less impressive, and the shareholders aren't going to be happy because they're not making like huge ROI over potentially really short amounts of time. But that's probably where we're going to be kind of going, at least my guess right now.
Yeah, I think so. I think so too. We just have to be, well, not we, but the owners of these big companies would have to be comfortable making less profit, I guess.
Yeah, good luck with that. They're going to fight that tooth and nail.
Oh, okay. We're going to move away from manufacturing and bring your manufacturing back and talk about you in a little bit more detail. Let's talk about you going through the Techstars accelerator in 2019. What was that experience like?
It was awesome. I thoroughly enjoyed Techstars, especially since it wasn't in Texas during the summer. It was up in Connecticut is the program that we did because it was partnered with Stanley Black & Decker, and we basically got to skip the worst part of the summer in 2019. So that was a nice little fun bit, but it was just being in the same environment with 9 other companies all working on really cool stuff, just going as hard as we could for those 3 months was an awesome environment to be in. And the chunk of money they threw at us was pretty useful too, because that got our second gen prototype mostly built and ready to go. All in all, solid experience.
Solid experience. So in your opinion, then, this is 2023. You think accelerators or incubators are suitable for hardware startups nowadays?
Some of them. Knowing what I know now, I'm not. So for us, Techstars was too short. It was too short and maybe not quite enough money. Hardware is hard. Atoms have a hard cost to them. It's just more expensive. But the bigger thing is time, because you can do a whole lot with software in 3 months, even though technically it was only like a month. You spend the first month pretty much spending all of your time meeting mentors and meeting potential investors and doing all these things. Then you spend the middle month actually working, and then you spend the third month starting to gear up for demo day, which means you basically got a month to maybe 6 weeks of actual work. You can do a decent amount of progress with software in 6 weeks. You are much more hard pressed to do a significant amount of progress with hardware in 6 weeks, just because it takes time to make stuff. Like every screw you have to screw into place, every nut you have to tighten down, all has a time cost. And then you had to figure out where it goes and design all the parts and do all those different things and then buy them and order them, and then they have to get shipped and show up. And it just kind of all stacks up. There are a few out there. Y Combinator, I think, is really solid just because they now bumped up how much money they put in and their kind of network and prestige. There are a few other ones too. There's one that is called, I want to say it's Hacks, H-A-X.
Hacks?
Yeah.
Okay.
I think they have locations both out on the West and East Coast, but it's a 6-month program. So it's, I think, $250,000, but it goes over 6 months. They have a fully flushed out and ready to go makerspace with tons of different equipment to be able to use. That one seems like actually a compelling option for hardware and hard tech startups, because that's the biggest thing is you'd want someone that, one, if you're talking about a defined program, to actually have enough time to be able to get a decent amount of work done, and ideally that it comes with access to the types of equipment that would be beneficial to accelerating that work. Because if you're going to be going through an accelerator, the whole point is to speed up your actual progress. One of the best ways to do that is providing access to the types of equipment and things that you otherwise would be hard pressed to easily find.
Yeah. Yeah, I'm reminded about how not accelerators or incubators, but just general maker spaces went out of business like over the past few years.
Yeah, a lot of that was, I think they overestimated how many makers, like hobbyist makers, are out there that would be willing to pay to be in those spaces, and they massively overextended themselves and just spread way too fast. It's a good concept, but I think if they had done it more targeted at specific types of customers, it could have been much more sustainable on the long term. But they wouldn't have spread as much as fast and as far, because having like a tech shop or something like that, like one of those in every city, was, I'd say, ambitious at best and probably foolish at worst.
Yeah, but wow, it was very useful for me, for example. I used to spend all night,
But how many other people were in there spending all night?
Yeah, that's true.
Yeah, that's the kickers, because they would have like dozens of desks that you could rent, and there'd be like 4 people in there. And I mean, it was cool.
All the office spaces were empty.
That doesn't work as a business model if you don't have customers to buy the thing that you're selling. It can be amazingly cool and useful for a very small set of customers, but unless they're willing to pay a whole lot of money to cover those things, that doesn't really work. Because if you're trying to do like a low-cost, high-volume business and you only have a low number of customers, that doesn't work.
Yeah, and I think this is more like, I had this discussion with a friend of mine, Brett, about how this is a grassroots problem. Right, you have people still studying like the hardware type engineering degrees in mechanical engineering, electrical engineering, and things like that, but who don't really see a future in the space. And some of them,
which is ironic. Okay.
Yeah, they don't. Well, it comes down to money, right? You see someone who went to school with you, right, but studied computer engineering or computer science, and you're like, oh, maybe I should go learn how to code too. Like, of course, you already know how to code, but like learn how to, build websites or learn some machine learning and things like that. And that creates a problem where you have a grassroots problem where people are not even interested in jobs in their space, much less. Talk less of being interested in building companies, right? And I'm wondering if the topic what we talked about earlier on, bringing manufacturing back would help in that sense, or if this trend is going to continue.
I mean, I think it would definitely help if that is actually like a really solid and defined trend. I think at the end of the day, you're just going to have, like, for me, I know that if I had gone into software or cared about that at all, I could be making a whole lot more money doing that. I'm not sure you could pay me enough to do straight coding as a job. That just sounds awful. Yeah. I mean, just awful. I like working with actual things. I like designing, I like building, I like manufacturing, I like the actual physical world, because at the end of the day, that's what we actually interact with. I mean, you can make all of the apps and everything you want and all of the better software, but we still live in the physical world and interact with physical things, and the way that you improve the physical world is by having better physical things. I mean, that's the tangible progress. The other stuff is the really fast and flashy, but it never has seemed as tangible for me. Some aspects of it are really, really cool when you're talking about like ways to improve connectivity or improve the way a process works or improve the way people are able to get work done or work together or interact, or all of those things are fantastic. But at the end of the day, we still live in the physical world, and having improvements of the physical world is what you are going to notice most when it comes to tangible benefits to our society and species long term.
So it's easy for you and I to have that discussion because we're builders, we're entrepreneurs. But how do you make that exciting to someone who is going to get an $80,000 job, if that, and is seeing his own classmates getting double of that? You know, how do you say that to someone who is not like excited about building something of their own, you know, has built multiple startups and things like that?
Well, I mean, one, it helps to build cool things. Because I guarantee you that a lot of those people now seeing that it's possible to go work for a rocket startup or something like that definitely helps. That didn't exist really like 10 years ago. And now there's more than I can count, which means they're needing aerospace engineers, aeronautical engineers, mechanical engineers, electrical engineers, people who work on propulsion, chemicals, all of that stuff. And that's a really cool thing to go into because you're talking about doing stuff that we haven't really done as a country since the big push in the 60s and 70s with NASA. And like, it's been a really long time since there was that enthusiasm in that industry for that product and for that possibility, to where now you've got lots of people going into those education spaces of kids coming out of high school and going to get aerospace engineering or they literally want to be a rocket engineer, all those things. It's now that we're starting to have some really cool, what I call like sci-fi tech is not just like on the far horizon. It's like right over there. You can see it. Like that makes it much more tangible and appealing because we can now very easily see a near time period of where there are thousands, if not millions, of people living and working on the moon and living and working in space. We would always been thinking about that since the 50s and the 60s, but it was that thing that'll happen 100 or 200 or 300 years from now. And now we're looking at it as, no, that's probably just a couple of decades off because launch costs are plummeting. All of these other things are getting built out. All of these other things are getting figured out. To where that's a very real near-term possibility that's a very exciting possibility. And I think there's going to be a lot of people that want to work on those type of problems and those type of systems. And we're also seeing things like we're actually pretty close to finally having flying cars thanks to eVTOLs and stuff like that, to where it's a lot of these things that have been, fusion is right around the corner. A lot of these things that people have been talking about and dreaming about for decades now, but they always seemed so far off that it was almost purely hypothetical. And now you're talking about that, oh no, we can touch it. It's right there.
Yeah. So let's hype up SpaceX, NVIDIA, other companies, whatever that company is that's trying to build that fusion technology for Microsoft in 2028. Hype them up in the mainstream, not just in niches and things like that. Maybe on the same level as ChatGPT or something like that.
I mean, that'd be cool. Hype is always a hard thing to actively do. That tends to be much more of an organic thing of what people kind of jump on and get obsessed about. I can entirely understand.
$20 billion will create hype, though.
True.
That's what it got. You know?
Yeah, but they got it because of the hype. Not it wasn't that they got hype and then spent, or it wasn't that they got $20 billion and then spent it on making hype. It was everyone was looking at it, holy crap, look at what this crazy thing can do.
Yeah.
Dump money into it because we think we can make money off of it.
Yeah. Okay. Because right now, all you got is personalities on the hardware side. Without Elon, there'll probably be much less hype for space or SpaceX or something like that.
Yeah, and I'm not sure necessarily all the hype that he brings is actually good. I'd say at this point, as for the last couple of years, it's almost negative because you've seen that, like, you look at SpaceX and Tesla stock and kind of just the way that they're viewed by consumers has been massively eroded over the last few years because of his antics, to be charitable. It definitely does help. I think what's The more impressive thing and the more sustainable and long-term thing is when you're talking about that it's the actual things being built that excite people, as opposed to like a Tony Stark wannabe talking a lot about it. Like that has its place and can be beneficial, but when that's the primary go-to-market strategy, as to sort of say, then I don't think that's sustainable. But if it's more so that there are dozens of other companies working on these same launch problems, the problems of getting to space cost effectively, getting lots of equipment to space to where we can start fully taking advantage of industrializing that new frontier, it's still happening and it's still exciting, and we're still going to see the tangible benefits of it. It's just not all of those leaders and CEOs are standing up with a microphone saying crazy stuff all the time.
Okay. It seems like Elon is you either love him or you hate him. It's like opinion on him is like divided nowadays, no?
Yeah, I mean, it used to be that, and I was all for and still am on the stuff that he's built. I just now find him to be very annoying and distractive in a detrimental way to what he's actually trying to build. Like it seems in a lot of ways that he is now actively getting in his own way, whether it because of, I don't know, ego or too much money or what. But when it was just focused on SpaceX and Tesla and these other kind of serious things, that's when it made total sense. And I was all, hell yeah, rock and roll, let's do it. Now it's just distraction after distraction after distraction that just seems to be eroding the public's view on, even when he's not talking about Tesla or SpaceX, he's still eroding the public's opinion of them because he is so much the face of those things to where people can no longer separate Tesla from Elon. So when he starts saying really crazy stuff or doing crazy stuff, like this whole thing with Twitter is just insane. And a lot of it is affecting the things that he spent decades building. Solely because he can't seem to get out of his own way now.
Wow.
Like literally suggesting a measuring contest with Zuckerberg. I don't get it. Like that's one of those things that, like, I don't hate him. I just don't understand what is going on with him now, and why he has lost so much focus on actually doing the things that matter.
What's funny about that is the Coliseum is not set up for that right now, and they want to fight there. So I don't know. It's okay. So here's my thing. I tend to be neutral on a lot of things, right? A lot of subjects, including the Elon subject. But how else can you get the message to the general public about interesting things that are happening in space with physical technologies and all that outside of interesting personalities? You know, that's what we try to do on this podcast. But the podcast is brand new, it's growing, and hopefully we're able to get the message out. We get bigger very soon, and things, and you know, will become mainstream. But there's a company out of California, Vada Industries, right? They're trying to manufacture in space.
Yeah, they're doing chemicals and stuff like that. They just started actually working on the LT or L something 99. They were doing their own validations of the supposed room temperature superconductor.
Yeah. So it's easy for those of us in the space to think that everyone knows what's happening, right? We know, okay, there's this semiconductor thing that's happening. It happened over the past few weeks. And then there's the next thing. And then there's the next thing. But that's just you and I and a few thousand other people, right?
Well, I think the way that people know and become aware of it is by amazing results. Because if they produce things that dramatically change the way people's lives work, they become aware of them.
The problem, though, is people don't know how their life gets changed. For example, you know, I had a discussion again with Brett about how the reason why your phone is faster, better, and all that is not because of Apple. It's because of some small company, startup somewhere that did all the work, but no one knows about them.
But does it matter? They still got paid. They still got successful. They still did all those things. Not everyone needs to be famous to change the world.
But if Apple doesn't, Apple, Samsung, whoever, doesn't make those, if they don't push the significance of those changes beyond just, oh, we made the iPhone faster, processor chip, A4 chip, whatever.
Well, they present it
Right.
in a way that the customers actually understand and can digest. Because if they went up there instead and said, like, hey, look at how much, like, we're now 0.67% more energy efficient because of this one company in this one area optimized this one chip, how amazing it is, everyone be in the audience would just go to sleep.
That's true.
But if they instead say, now it works better and it is faster and it will let you do these 3 new cool things,
Yeah.
then everyone's excited.
Yeah.
Now, granted, there was a whole lot of work that maybe went into that, and maybe they're not talking about the specifics of it, but they're still now excited about the new developments that are happening, even if they don't understand every single bit of the technological development that went to making those new developments possible.
Yeah. So that's good for the consumer, but how does that benefit the mechanical engineer in his third year, in the junior year, who would have been way more excited by the niche technologies that went into that?
Well, if they're the type of person that is excited about that, they'll probably find it anyways.
Without a microphone, without someone on a microphone pushing it.
Maybe.
All they would know is Apple. All they would know is I want to work for Apple. They wouldn't know about like the smaller, medium-sized companies.
I mean, that's a starting point, though, because a lot of people want to work for Apple and try to go to work for Apple and don't end up getting that job, and then are saying like, hey, I've got this education, I've got this skill set, what else is out there? And they end up going to one of those smaller companies.
Okay. I guess, well, that's one way to look at it. Yeah. Okay, let's move on to something happier. I know, it's a pun on the next discussion. You host a hardware happy hour here in Austin every month. Talk about the motivation for that as well as the progress you've made so far with that.
So that started because me and my buddy Sean were literally at the Austin Techstars demo day back in October of 2022. One, we were complaining about the fact that they don't actually get on stage and pitch anymore, that they did pre-recorded and edited videos for their pitch, which annoys me to no end, because if you're going to be a CEO, you need to be able to actually get up and sell what you're doing in a clear, coherent way on the spot, even in front of hundreds or thousands of people. But anyway, the other thing that we were kind of complaining about as we stood in the back was that here in Austin, there are very few really good kind of communities and meetups for hardware, which is kind of ironic because we still have a lot of manufacturing in Austin. It was where Dell started. It was has a strong hardware and manufacturing background, but there just weren't really any, or very few, if any, good kind of communities or meetups. So we decided, okay, well, we'll just do it ourselves. And we do it every first Thursday. We move it around. So every month so far, it's been at a different venue. And we usually have 30 to 40 people show up, which is we're pretty happy with, because especially our whole concept from the beginning was let's put the absolute minimum amount of effort into this and see what happens, because if people are excited and start showing up about it, then that's a good sign. So we just create an Eventbrite page every month, and we'll throw it up on our LinkedIn and any kind of Slack groups or Discord groups we're a part of. And I think the first one that we did, the day of it, I had at least 2 or 3 different people. I was down at Capital Factory that day for a bunch of meetings, and I had probably 2 or 3 different people down there come up to me and ask, hey, have you heard about this really cool hardware happy hour that's happening tonight? If you haven't, you should definitely come. And every time I had to kind of laugh, I was like, you didn't scroll all the way to the bottom of the page, did you?
Host.
No, I was like, okay, because it's my name and Sean's on it, because we're the ones starting it. And yeah, it's been really fantastic to see how enthusiastic people are about actually having that type of opportunity and community here in Austin, because you can find an infinite number of crypto happy hours, software, SaaS, CPG. Now I'm sure there's tons of AI meetups all the time, but there are still very few that are actually focused just on kind of hardware and deep tech, because I don't know, I guess people just don't associate Austin too much with that.
Mm-hmm.
And yeah, it's been fantastic. We had the last one was last week, a week ago today. And probably had 20 or 30 people show up. People will kind of come and go over the span of the 2.5 hours that we have it going on.
Fantastic. So I guess you're contributing to solving the grassroots problem in a sense. I mean, if people know that it's a community of people just like them, kind of helps them stay on track. Know that they're not alone, I guess.
It also helps a whole lot too of helping people make really good connections.
Mm-hmm.
One of the better stories that came out of it, this is one of the things that Sean and I were thinking about when we started this, was facilitating just serendipitous interactions.
Mm-hmm.
And not this last one, but the one before it. I was having a conversation with two guys that I already know. One of them was someone that we've worked with as a freelancer. The other one was a customer who's now going to be involved in the next thing I'm starting. But we were talking about, like, they had never met, so they were getting introduced. One of them's an electrical engineer. The other one's a mechanical engineer with a decent amount of electrical experience. They're talking about what they do, what they worked on, and my buddy Greg was talking about how he has a whole lot of experience with like certifications, like Underwriters Laboratory that does safety and testing and certifications for products and stuff like that. He worked on a lot of things like that and had a lot of experience with it. And that was what he was talking about. And then not 20 seconds later, another guy shows up, jumps in the conversation, just, hey, wanted to meet you because you're one of the people kind of starting this and wanted to say thank you for doing this. And I no kidding, he immediately asked, like, hey, do you know anyone here that has experience with like certifications and stuff like that for Underwriters Laboratory? And like, is exactly what Greg was just talking about. To all three of us kind of look at each other, and we thought he was making fun. Like, he was joking a bit, saying, oh, you heard the conversation and kind of jumped in, because the way he was saying it was so kind of enthusiastic that it almost sounded like he was just kind of jumping in and having some fun with it. Dead serious. He was 100% serious. He was like, and he'd already asked 2 or 3 other people at the place if anyone had experience. So I just immediately say, you need to talk to Greg, because that's what the majority of his experience is. And I'm not exactly sure what kind of came of that, but that type of interaction that otherwise would be very hard to happen can happen when you have a whole bunch of people who are enthusiastic about a general subject, but that have broadly different backgrounds and experiences. You get them all in one place together with no agenda or expectations other than just having fun talking about stuff that you care about with other people who care about the same stuff.
Yeah. It's pretty good. Do you have any plans to make this like bigger, or you just gonna do it every month, see where it goes?
At minimum, we'll just kind of keep it where it is. We might make it bigger. There's another outfit here in Austin called Fiesta. I've known them since pretty much the first one.
You can get lost in there.
Yeah,
with Fiesta, like, it's everybody and anybody.
Cherie, man, she is amazing at all of that stuff. And I've had multiple conversations with her about us being more kind of involved with them. They usually give us a shout out on their calendar of events coming up whenever we have our thing going on. If it does kind of expand and grow, we want it to be, very organic. Like, we don't want to be trying to force it. We don't want to be trying to add in like extra programming or forcing people to listen to talks and stuff like that. We want it to be like, hey, all of y'all love this type of cool, nerdy hardware stuff. Y'all love hanging out. Y'all love coming and talking and chilling and just having a good time with zero expectations or agenda. And if that continues to grow and becomes a bigger thing, awesome. If it stays right around where it is, like 30 or maybe 40 people showing up every month, I'm also fine with that. It's a fun way to spend the first Thursday of every month. And it's one of the things I genuinely look forward to, of just being able to go hang out somewhere, sit, and have what I know are going to be really fun and cool conversations.
Fantastic. So if anyone listening to this podcast wants to reach out to you, do they reach out to you via the happy hour, or how else?
That and email. I'm LinkedIn is usually
probably.
LinkedIn is usually where I spend most of my time. I hate Twitter or X, whatever the hell that is. I don't really do that much on Instagram. I don't know. I'm not a social media person because I just kind of find it to bring the worst out of people. But I like LinkedIn because it's at least mostly focused on like, hey, professional stuff, building stuff, like what you're actually doing. So LinkedIn is usually a good option.
Okay.
And then, just search hardware happy hour. Like our logo is literally H cubed because we're nerds. And our slogan is literally atoms greater than bits. Because we like atoms more than bits.
They are greater than bits. Bits are an imagination. Atoms are real.
This is very true. 100% agree. 100% agree.
So Riley, it was good having you here today. Thanks for coming.
Thanks for having me. This was a lot of fun, and I really like your whole setup, and you did a very, very good job with the studio setup.
Well, thank you. Appreciate it. Well, this has been another episode of the Hard Tech Podcast. I'll see you all on the next one. Thank you. If you enjoyed this episode, please like and share the video. Also subscribe to the channel and hit that notification bell so that you can stay up to date with the future of physical technologies relating to robotics, energy, healthcare, transportation, and more.